Hello, everyone. This is a very quick one. Someone asked me about how to draw a phylogenetic tree, and I felt it's going to be useful for everyone too. So, here is a quick drop down of how to quickly do a phylogenetic tree. So, let's assume that you do not have a sequence already. So, I'm here on the page of the NCBI and I've downloaded some sequences. Okay, let's assume you don't know how to download the sequence also from NCBI. Just go to this website ncbi.nlm.naih.gov. So click on the NCBI icon and just search. And then in our search, you can search for anything you want to download. Maybe this is Edis Album Pictures CO1. So when you search, the result page will come out. So you click on all the sequences you want to download, and after selecting, you can come here, click on send to, click on file, and then you can select faster or Jimback on summary or any type of a sequence file you want to download. Now I have downloaded the sequences I want to use, and the next thing is to just to open the BioEdit. So in BioEdit is used for the alignment of the sequences. So how do you align your sequences? And for manual trimming too, and other functions too. But for this part, we'll use it for alignment. So you open. So I saved my sequences on Notepad, and I saved it as phylogeny. I would load the sequences onto BioEdit. So these sequences I downloaded from NCBI. Aedes albopictus, Culex, Pipiens, Anopheles sinensis, and Anopheles gambiae. Now I'm going to edit, and then I'm going to run the sequences. So let's wait for that to run. It wouldn't take a lot of time. Yeah. So this is the alignment. So as you can see, there are different alignments because the sequence length of each of the species are different. We have Anopheles gambiae being longer than the rest. So, but we want to have a common ground for them so that we can compare. To do that, you can simply come here by clicking on this to show, for example, the four sequences on Aedes albopictus. So here, all sequences are similar. Here, as you can see, it is C throughout down here. So we do a manual trimming. So click on edit and you trim manually up to the point that all of them were the same. And then you come to the end also, check where all are the same. Now, meanwhile, the from the alignment set, we should be able to tell a story about the sequences that we are analyzing. Because this is a blind analysis. This is a blind analysis in the sense that I am not the owner of these sequences. I don't know the origin. So these are just secondary data from NCBI. These are not original data. So I expect that the alignment for Anopheles sinensis and Anopheles gambiae should be similar. For example, what do I mean by similar? We can see Culex and Aedes, the sequences, as you can see from all this region, they look more similar. So I expected that Anopheles sinensis and Anopheles gambiae should also look similar, but they are not. They do not look much alike to one another as I would have expected, unlike Culex and Aedes. So I kind of suspect the originality, the true nature of these sequences, because as expected, they fall in the same genus and they ought to be in the same, at least look alike to a certain level, unlike how QLX and ADs, how they look alike. Now, notwithstanding, our goal is just to show us how to do a phylogenetic tree. So now that we've been able to manually trim, the next thing is to save. Control save. Just press Control S. So Philo 3. Let's save as Philo 3. Now we are finished with that. As you can see, it's saved as a faster file. Now we'll come to these mega. We have mega X, mega 7, mega 8, mega 9. Each of the mega you're using, anyone. So just open the file session because I've loaded some files here already. Okay, file 03, open. It says the file is already activated. We like to use another one. Yes, I would like to use another one. The reason why it asked that was because I've already loaded some files already and I've already drawn the phylogenetic tree. Would like to create one now. So it will load. It will ask you, are you aligning or analyzing? I'm analyzing because I've aligned already with BioEdit. Now let's wait for that. It will bring also another option, nucleotide or protein sequences. It's of course nucleotide. Now this is necessary. It will have to convert your nucleotide sequences to protein sequences, protein coding nucleotide sequence data. So you have to do that. Now it will ask you, is it a standard or should you use a standard uh, genetic code to analyze your data, or you want to be specific? So since we know what we are dealing with, they are invertebrate mitochondria, okay, and then that's all. Now we'll move on to phylogeny. We can run maximum likelihood and neighbor joining tree. These are the two popular tree method that are being used. We click on neighbor joining tree because we want it to be fast. Now, okay, the bootstrap method is very important. Usually select it as 1000, and then the method is also important. I usually use Chimera too. Every method has its own specific usage and what their differences. So Chimera 2 parameter for the sake of this class. Okay, and then kabang. So we have the phylogenetic tree. So we have the phylogenetic tree now. Now, a short explanation, although not, is that ordinarily we expect here we have two nodes. Uh, one node, this is one node, and this is another node. What this signifies is that each node is like a family house, like the family of those that look alike. Now, what this, according to the our sequences, what this means is that in this family is totally different from this family. Now, I would have expected Anopheles gambiae to be aligned together with Anopheles sinensis, but it's very awkward to see the sequences aligning with QLEX and ADs. So, since the goal of this short video is just to show us how to make a phylogenetic tree, we've come to the end. But on a technical level, I have reservations regarding the sequences that were used in the analysis because Gambia is supposed to be its Anopheles sinensis. So that's it. So if you want to copy your sequences, you can copy your tree, or you can save your tree. You can save it as PDF, PNG, SVG, any file format you want, or you can copy it to the clipboard and then you paste it on the PowerPoint for more editing because you cannot edit here. You cannot edit here. So that's it.